Okay, let's go ahead and get started here on our next flip lesson, which is going to cover application problems with ratios and unit rates. Our learning target today is that you, the student, will apply rules of ratios and equivalent ratios to application problems, basically word problems, anything where you have to apply these skills. A box. Okay, so let's go ahead and jump into our first example here. Example 1, a box of Legos has a ratio of 3 blue bricks for every 8 red. If a pile of Legos has 48 red bricks, how many blue bricks are in the pile? So why don't we go ahead and start off this problem by just figuring out what our basic ratio is. And that's our basic ratio, 3 blue for every 8 red. So I'm going to put 3 here, 3 to 8. So this number represents the number of blue bricks. This represents the number of red. And then let's go ahead and figure out our other ratio, which is only going to have one number. So 48 red bricks. Now where are we going to put 48? We're going to put it right here. So we want everything to match up. So this represents red, so does this. So we want everything to match up, denominator to denominator, numerator to numerator. So we don't know what this number is. And in order to do that, in order to figure this out, we're just going to look at this like equivalent fractions. How many 8s are there in 48? Well, it's pretty simple. 8 times 6 is 48. So there's our multiplying factor. So what you're going to do up here is you're going to multiply 3 by the same exact number, which is going to be 6. So 3 times 6 is 18. There's the number of blue bricks. So 18 blue bricks. And that does it. Okay, here's our next example. Derek Rose scored 5 points for every 9 shots he attempted. So I'm going to go ahead and write that. 5 points. That represents the points he literally scored. 9 is going to go in the denominator. That represents how many shots he took, how many tries, how many attempts. If he scored 35 points, how many shots did he attempt? So where should we put 35? 35 is a points number, so we want to match it up with the other ratio. So points is on the top here, so let's put points on the top here. So 35 here, and this is going to be our unknown. So how many times does 5 factor into 35? Well, it factors into it by a factor of 7. And then do the same thing with 9. So this is just a matter of multiplying 9 times 7, and you get 63. According to this problem, Derek Rose took 63 shots. That sounds like a lot, probably is, but I just made up this ratio. Okay, let's go into example number 3 here. Part of Hubble's hallway has 32 white tiles and 20 black tiles. If you went to a different part of the hallway and counted 5 black, let's say you were looking at a particular section of the hallway, and you counted 5 black tiles, how many white would you expect in that section? Okay, so let's go ahead and write down our basic ratio. There's our basic ratio, 32. That represents the number of white tiles, and 20, and that represents the number of black tiles. Okay, so 32 to 20. You went to a different part of the hallway, counted 5 black. So where are we going to put 5? Well, we want it to match up with the other ratio, so we're going to put 5 down here. So that's going to represent 5, and this is going to be our unknown. Now to do this problem, to get from here to here, we have 20 and 5 here. It's not going to be a matter of multiplying. It's going to be a matter of dividing. And that could work too with fractions and ratios. So what can you divide 20 by to make 5? 20 divided by 4 is 5. And let's see if 32 divides by 4, and it does. So what's 32 divided by 4? You get 8. So you have 8 white. So you could expect if you went to another part of the school and kind of looked at a particular section of the hallway, that if you were to count 5 black tiles, you would expect there to be 8 white tiles in the general vicinity. Here's somewhat of a different problem. Example 4, the ratio of golf clubs to golf bags is 9 to 2, and that just means there's 9 golf clubs for every 2 golf bags. Is it possible that an equipment closet could have 44 items? Now let's pretend those 44 items only consist of bags and clubs. Okay, there's nothing else in there. There's no footballs or baseballs or volleyballs. Just golf equipment. Okay, so golf bags and golf clubs. So is this possible? So let's go ahead, and this time around, we're not going to solve it the way we did the other problems. We're just going to look at the ratio. So there's 9 golf clubs for every 2 bags. And let's go ahead and just kind of find some other ratios. All right, 9 to 2 is also equal to 18 to 4. So I multiplied by a factor of 2. That's how you make equivalent fractions, and that's also how you make equivalent ratios. Let's keep going. Instead of 9 times 2, let's do 9 times 3. 9 times 3 is 27. 2 times 3 is 6. I'm going to keep going here. I'm going to multiply by 4. 9 times 4 is 36, and 2 times 4 is 8. Now if you look carefully here, you'll notice that the top numbers here in our ratio are all multiples of 9, and in order. 9, 18, 27, 36. So I'm going to just do a few more just for good luck here. Get the next multiple of 9 is 45, and the next one after that is 54. I'm going to stop there because I ran out of room. Okay, down here you have multiples of, looks like you have multiples of 2. So 2, 4, 6, 8, 10, and 12. Okay, so now let's go back to the problem and figure this out. Is it possible that it could have 44 items? I mean, that's the part we need to figure out. And if you look at all those numbers, you don't see 44 in there. So that's the thing. Do you see a 44 in there? And I don't. But that doesn't mean the closet doesn't have a ratio of golf clubs to bags that equals 9 to 2. So what do I mean by this? What we have to really look at is, look at the ratios themselves. This ratio, for instance, 9 to 2. If that's the actual number, if that literally is the number of clubs and bags, then that means there's 11 things. There's 9 plus 2 is 11. That means there's 11 clubs and bags in the closet. If this is literally our ratio, there's exactly 18 clubs and there's exactly 4 bags, then that means there's 22 items or things in the closet. If this is literally our ratio, if that's exactly how many items are in there, then that comes up to 33 items. So hopefully at this point you're looking at this and you're noticing a pattern. Just like we had a pattern with the numerators and denominators, we had a pattern with the total, the sum. These numbers are all multiples of 11. So 11, 22, 33, and then this one we could expect to be 44. 36 plus 8 is 44. So 44 items. And there you go. And now we know the answer to this question. And the answer to this question is yes. Is this possible? Yeah. And we didn't guess. We used our information about ratios to figure it out. So it is possible to have 44 items. It's possible to have any multiple of 11. So 55 or 66 or 77 or 110, 132. Based on that ratio, I would expect multiples of 11. So kind of an interesting problem there, just using ratios in a different way.